So I'm going to open this up with a bit of a controversial statement, which is I believe that analytics is a constant underachiever and has been for a while. Now, that's an odd thing to come from somebody who has spent their entire career in analytics. But the reason I'm saying this is because all of those surveys and a lot of the research shows that organizations are continuously having a difficult time leveraging technology to get insight out of data. And so, if you look back to the 90s and the 2000s, when business intelligence was the buzzword and the technology of choice for all the folks who wanted to harness the value in data, there were lots of good technologies like the data warehouses, dashboards and reports, which we still use today. But a lot of those projects actually didn't succeed. Now, big data rolled around in about 2010 with technologies like Hadoop and MapReduce, and gave us a lot of opportunity to look at much larger data sets and explore much more interesting problems with the rise of machine learning and technologies like Spark. But again, what we're seeing now is many of those technologies, many of those data lakes and platforms are either being retired or they still haven't quite given us that edge that we want for the majority of us and for the majority of enterprises. And of course, in the last few years, AI became sort of the latest and greatest technology that everybody wants to take advantage of. And the truth of the matter is, until you sort of foundationally figured out how to make data useful in your organization and build some of those foundational components, it's still really hard to harness the value in AI. And so, and that is it's a very difficult problem to solve. And but luckily, there are ways in which you can actually harness the value in AI today, and we will talk about how to do that. So again, as I mentioned, a lot of this is a research that came out of New Vantage Partners, and it's a publicly available piece of research that you can look up. And the idea is that those of us who are very good at leveraging data and have been for a long time, who didn't sort of fail at analytics for the last couple of decades, are still better at it than so many more of other companies and businesses out there. And the idea is you have to forge the data culture first in your organization. So many of us are fearing that we'll be disrupted by those businesses that do know how to leverage AI, and that's exactly what's happening. So alternatively, if you think about how our world has changed in the last couple of decades, applications is what is driving a lot of the innovation and a lot of the change. And so the idea is, if we look to applications today, these are some of our customer examples that are disrupting anything from medicine to cryptocurrency, and anything from the way creative design gets done today to banking, to travel, gaming, and more. And so this is actually pretty amazing. So what I'm going to be talking to you about today is how to use applications together with AI in order to initiate and actually see through this sort of change from the beginning to completion. So what we will look at in a form of a demo is this idea of an e-commerce application. Now, of course, we could have chosen any application at all in any of the use cases that I just pointed out, but e-commerce is sort of very easy to understand. And so we'll start with an application that helps you shop for products like we do every day. And what we will do is we will build a recommendation engine using machine learning to get personalized product recommendations. And we will also use a piece of AI to enable that shopping over an application or a mobile device without actually going onto the website and putting things in our shopping cart ourselves. And in fact, this is sort of the new way in which a lot a lot of interaction happens with over chatbots and technologies that understand language and voice. And so we will combine all those three components into what I have been calling an intelligent app. And in fact, it's sort of catching on as an industry term now. You can talk about intelligent things and autonomous things, whatever term you use. The idea is that this is a piece of technology that combines multiple applications, multiple components that can seamlessly interact with one another to give you a different and a superior experience at whatever you're doing. So what is an intelligent app? Well, we've already been talking about it for a little while, so no surprises here. It is something that's been trending for quite some time now. And again, the terminology may vary. But the idea is you're using a combination of real-time analytics, machine learning, AI, and you're automating some form of a task as well as providing knowledge that is sort of not obvious to the user. So if you think about, whether it's product recommendations or detecting fraud, there is some form of decision support to enable us to do our job better. And that's exactly why these applications are disrupting their respective industries. So why, in fact, has it been hard to build these applications? Why have we not been doing this in early 2000s and certainly up to this point? Why are there so few companies who are actually harnessing this? Well, if you think about who actually builds these intelligent applications, there are a few different personas. At the very beginning of an application sort of life cycle, there are developers, right, who have a very cyclical way of sort of defining requirements, building and releasing. Most of the time they're using agile methodology, but they're very much involved in continuously evolving that application, right? And then there's data scientists. So for most of machine learning and AI types of workloads, there's a very linear actually workflow. And in fact, many of us struggle with how to make that workflow more productive. So you start with getting some data, perhaps lots of data, you prep it, and you build your model, you train it and evaluate it, perhaps you try multiple different algorithms, and then you get some insight, potentially valuable, potentially not, but how do you operationalize it? So maybe you'll visualize it, maybe you'll deploy the model to be used by a few folks in your organization, and you're predicting churn or you making great product recommendations, but how do you actually put it in the hands of your customers? And so another persona that helps put these two pieces together, but also is often involved in its own silo, are data engineers. And they're evolving as a new category of jobs, of folks who are busy making data available to others in their organization. They may work with developers, they may work with data scientists, but their job is to get data, make it useful, and then scale those processes, especially in the cloud. That is incredibly important, right? And so the premise here is that these three personas, and there could be other ones in your organization that are slightly different, they actually don't work together very well, or they're involved in their own workflows and their own silos. And so actually putting all of this together is a bit of a challenge. And so it's both about building that data culture that I've been talking about, but it's also about giving them the right tools to actually make the products of their work useful. So we'll talk about how to do that. So let's start with talking about the demo that I promised you. And you'll definitely see it in action in just a little bit. So what we built here to kind of illustrate this intelligent app framework and ecosystem is what we call the swag store. So everybody loves MongoDB swag. And at the very start, we basically built a nothing more than a shopping cart and application that allows you to browse for your favorite MongoDB swag, place it in cart, check out, look at your orders, and perhaps get restocking notifications when your favorite sweatshirt or backpack is back in stock. So we did this by using MongoDB Stitch as well as React for the front end to actually build kind of the backbone of this demo. So for those of you who are maybe not so familiar with Stitch, Stitch is the MongoDB serverless platform that allows you to get your app out the door so much faster than before, right? So it simplifies your access to data, and it gives you the ability to write less code, and most importantly, focus on really the most useful and differentiating work that you can be doing as a developer, as opposed to making things like REST calls or providing service hookups or providing authentication. So all of that was actually done using Stitch and using Stitch's UI for more configuration than actually actual code development. And as I'm sure you have heard, we also have the mobile platform called MongoDB Realm, which is going to be merging with Stitch in the near term. So all of what I just said will apply to building mobile applications as well, which is incredibly powerful because, as we know, every application today is pretty much mobile. So a little bit more about what services we've used for Stitch. So first of them is Stitch Query Anywhere. And that exposes your documents and your data in MongoDB to allow you to have secure access to data for any application that you build. Stitch Functions allows us to write JavaScript functions and express complex logic that can be associated with service integrations or API calls, and we'll see how to do that. And then Triggers finally allows us to propagate data changes and events across the ecosystem, or potentially respond to changes internally in the database and execute some form of logic expressed in that Stitch function. So those are kind of the three components to keep an eye out, because we'll be talking about them more in this webinar. So how did we build the backbone of our demo, the actual operational application here? So as I've already mentioned, we use React for the UI components and routes, and as well as Stitch for some basic application flow control. So things like putting things in the shopping cart or providing a checkout experience. We also, for the purposes of kind of building a personalized recommendation engine, we also, as well as things like checkout, we also had to enable authentication, right? So if you wanted to log in and view your specific orders, we enabled authentication with Google. And we also provided notifications through Twilio to enable restocking notifications. So if I signed up to get a notification, I could enable it on my mobile device as well as over email. So that's pretty useful. And MongoDB Stitch, again, was in charge of taking all of that logic that I just described and expressing it using functions, using rules, as well as triggers and service integrations, which is another piece of component of Stitch that I haven't quite talked about yet, but I will in just a little while. And that's going to be a pretty important part of our demo. And then obviously we built this on MongoDB Atlas. We used our document model because it's the best way and the easiest way to express how data works together in today's world. And since we all think in objects, documents is sort of the best way to represent that kind of an object model. And needless to say, our demo is in the cloud. It's global. It's scalable. You can access it from anywhere, as sort of every application should be today. It's pretty much table stakes. So the next thing we said, well, that's great. We have an application to start, but how about bolting on a recommendation engine. Now, recommendation engines have been around for a long, long while, and the most basic one actually wouldn't need any machine learning at all. But the expectations today are such that your store or your shopping experience is really personalized to you. And so we did actually end up using a machine learning model to express a more complex form of recommendation engine. So how did we do that? So the basic premise was, when I have my shopping experience, I start out by logging in, and what I will see is a new tab or rather a new component of my store, my web page, and that'll be a ribbon at the bottom of the page giving me my personalized product recommendations. So let's just take a look at what that actually looks like. So here's my swag store, and at the moment I'm logged in as somebody who doesn't have any recommendations, but basically I have my apparel here, I have various products, I have bags and other categories, and I also can have a profile, and I can put things in my shopping cart quite easily. So if I go back to my homepage, nothing special about it here. But if I go ahead and sign in as me now, what I should see is that recommendation ribbon popping up, giving me the opportunity to perhaps get a vintage hoodie. And I'll put it in my cart and go back home, and maybe I also want this laptop back. So pretty cool. So how about signing in with another user? Well, I'm going to go ahead and sign in as Jasper, as my dog. Or maybe I'll just, since it's asking me to verify, I'll choose another user. I'll use my personal email here. And as you see, because I logged in as a different user, I'm actually getting a different set of products to peruse and potentially to purchase. So it looks pretty simple, but let's take a look at how we actually built this. So as we've already described, the application was built there using Stitch, Atlas, and that's kind of the basic, cart experience, putting things in the shopping cart that you saw. Now, the actual product recommendation engine that was giving me different recommendations based on who I was signed in as was built using Google Cloud. And we actually used Google Cloud for tuning and training my model, which was built in TensorFlow. The algorithm came from TensorFlow libraries, and it's called WALS, which is basically a fairly standardized way to look at a matrix and reduce a matrix of products based on who selected them. So it's really not about me and my shopping history. It's looking at sort of people like me based on a variety of shopping histories. So it's not, it's fairly sophisticated in the fact that it's looking at a lot of shopping history across multiple users, and it's actually not making any assumptions about who I am as a user and what my explicit explicit features as a user are. And we'll talk a little bit about that as well. So Stitch was actually the glue that brought that recommendation engine into our application, and we'll also take a look at that. And then obviously, to actually serve up those recommendations for Stitch to pick them up, we needed to use something like Google Cloud endpoints in order to do that. And so that is also something that we enabled. So again, a very simple demo, but actually quite a bit going on under the covers. So remember, when we first started talking about how to build these intelligent apps and who does this. We talked about developers, data scientists, and data engineers. So who would do this work if you were building this at your company? Well, we believe that basically the developer would start with building the actual swag store. Then the data scientist would come in and build that model. And the data engineer would probably help the data scientist configure the cloud endpoints and actually serve the recommendations. So that's kind of the flow and how the personas interact together. And so as you can see, the data engineer would probably be responsible for helping scale this, but the developer would be involved in kind of making these pieces and these components come together. And so it's just sort of helpful to think about who does these things. Could it be all done by one team? Absolutely. That's exactly how we built this demo. But in larger organizations with multiple models and multiple apps, this is sort of a helpful breakdown to think through. So let's talk a little bit more about actual architecture of this. As I mentioned, there are multiple things going on under the covers, specifically with model training being done in TensorFlow using the Cloud ML from Google. And the training data actually uses cloud storage on Google Cloud. And portions of the output are being processed with BigQuery because basically the recommendation engine at the end of the day needs to do a couple of things. One of those things is returning a very simple result. And the other one is actually what sort of intuitively makes sense to all of us is if we've purchased something, we don't want to actually get that recommendation again. And so as part of this, as this process, you need to do some post-processing and kind of filter out everything that's that users already purchased. So you actually need to look at their purchase history from the past. And the actual code for serving up and obviously there's some orchestration involved in making sure that the model has fresh data, and then the fresh sort of product history, product purchase history is available to kind of prune that data set accordingly. And then finally, what you end up with is using Google's App Engine is a recommendation API with cloud endpoints, which can then interact with Stitch through a service call, effectively a REST call, and then can be made available to an actual user without really any knowledge of how many components are involved under the covers. And as we saw, we were using a browser client for this. So zooming in a little bit, the recommendation API, as I've already mentioned, uses effectively a factorization or a matrix reduction algorithm to look at across all the items and users and sort of map those and then come up with distinct factors that are specific to the users and to the items. Now, in the sort of a more traditional sense or sort of a discrete approach to this would be look at all the users, look at their demographics, anything else that you may know about them from their history, and then look at all the items, categorize them, and then come up with that matrix of factors or features and do sort of a more feature-based analysis. But and that would be more of a statistical approach rather than kind of a true machine learning approach, which is what we did here. And in fact, in the real world, as your catalog grows and grows, and as your user base gets more and more complex, or in a case of e-commerce, you may not even know who those users are. Some of those approaches are not really as useful today as they were 10 or 15 years ago. And so as I've already described, one of the parts that we need to actually do is filter out some of the data based on the actual purchase history so that our user, when he comes for a recommendation, doesn't get a recommendation of something that he's already purchased in the past. And so as such, that recommendation engine is fairly sophisticated in being able to provide both of those answers to kind of both of those questions. So the actual, once the model was put together and tested, the actual deployment was fairly straightforward. Obviously, we had to install the model code. As I've already mentioned, it runs in App Engine. And our data, our historical data, was placed into a cloud storage bucket where CloudML could easily access it. And once the training was done, that was sort of the output was also available in cloud storage. So, and this, by the way, the steps for this are published on Google's one of Google's tutorials. And once we come to the end of the webinar, I will provide the links. So in case you wanted to recreate this, you actually could. Now, the next part is sort of tuning, which if you've done much data science, you know that this is sort of what distinguishes the good data scientists or the very experienced ones from maybe not so experienced ones. And really, this is the art of data science. Now, or at least that was how it was in the past. So the whole idea of hyperparameter tuning is sort of optimizing, fitting a complex curve that you don't really know what it is, sort of optimizing your model. And the beauty of Google Cloud these days and sort of the modern sophisticated machine learning frameworks is that this step happens pretty much automatically. So all at the end of the day, we had X number of epochs, and we sort of said these are our thresholds, and we were able to run a few simple scripts and kind of do this, rank the trials and come up with sort of the best result, pretty much with very little human interaction or human involvement. And in fact, if you look at kind of where this part of data science is going, the latest and greatest experiment that Google has put together was around AlphaGo and kind of fitting that curve was done either by a piece of AI or the best data scientists at Google. And AI actually, which is the blue curve here, kind of outperformed the humans. So the idea of AI tuning your models is actually pretty interesting, and certainly something worth exploring. But this is the whole idea behind automating some of these, or at least augmenting some of these very intensive human tasks. So I thought this was pretty cool. So the next step would be to generate our recommendations, right? And as I've already mentioned, we used Google Cloud Endpoints to do this. Our input was a simple Python script to basically do this. The inputs were the users, the items, and then the latent factors, which is what was the product of tuning our model and training and tuning our model, and then also the number of desired recommendations. So that work actually ended up boiling down to a simple call, right, into the cloud endpoints. And this is exactly where Stitch will come into play in just a second. And the answer that the model generated was a list of items, which then got mapped back to the product catalog, which is what you saw in the demo. So again, the idea here is that we basically have simplified this process and productionalized that hard work that a data scientist would go through in order to come up with such a model, by making it very easy to consume for an application. So then we use Stitch to serve these recommendations. And as I've already described, we've talked about functions a little bit, which is what allows us to build complex logic and orchestrate multiple data and data pieces, as well as client requests and services. And needless to say, it's built as a serverless platform, so it can scale really without on demand, without anybody having to turn the knobs and dials. So the function, when something like this, we obviously have the user who's logged in, who have their information, as you saw me logging in. And then we got the list of product recommendations using this call to a service integration, which we configured in Stitch. So that's another kind of component that I briefly mentioned, but hadn't got into much detail about yet. But the idea is that we are able to configure either a bidirectional, effectively a bidirectional hook into another web service, another application, anything. And that's actually, by the way, how authentication with Google happens. So we've got a number of pre-built service integrations to Twilio, to Google, et cetera, but you can also build your own. So in this case, using this feature, we actually built our own. And once that call was completed, it came back with a list of product recommendations, as you saw in the previous slide. And then we're able to actually update the user profile with that list. So, and effectively, the only two interactions these two stacks have is that HTTP GET request through that cloud endpoint. So that was pretty fun. And then we decided, okay, the latest in shopping is obviously not recommendation engines. A lot of what happens today is the ability to interact with a piece of AI, whether that's for to get help or to shop. And so as sort of the natural language processing has become more and more sophisticated, chatbots are pretty much everywhere. And so we decided to enable our Swag store with a chatbot. So the premise was that you can shop, you can have the same experience of shopping for products via a chat interface. And we chose Slack here just to be just to have something other than a different kind of web interface. Obviously, you could do this for a web interface. You could do this across kind of a number of applications or mobile apps. So let's take a look at what that looks like. Oh, that's not good. Apologies here as I sign back in. And we will be on our way once again. So let's take a look at now a Slack interface. So we and hopefully I'm just gonna make sure I'm still sharing. Great. So so the Slack interface, everybody's familiar with it. As you can see, I was testing it earlier, so I can say hello to my my piece of AI, and this chatbot will respond. Hi, how are you? I'm going to say, can you help me? And I get a response. Ask me for some examples. All right, give me some examples. So the response is that you can ask me for a specific item, and you can try to kind of be as specific as you'd like to be. So I'm going to say, find me an umbrella. Although it's a beautiful day here in California, and I shouldn't have to use one today. So as you can see, it found me an umbrella. So how about from my Swag store? Well, let's just say, find me a black t-shirt. And there's a t-shirt with Stitch. How about another item? How about find a white jacket? Well, it's not quite white, but it has some white in it. So if I decided that I wanted to go ahead and buy that, it will take me directly back to my swag store where I can put it into a cart and be on my merry way. So what you saw just now, let's talk about sort of what happened there and how we actually made it all work. So already, as you saw, our experience, even though Slack was the means with which we interacted with our store didn't go anywhere. In fact, I was redirected right back to it in order to get to actually be actionable, actually put things in my cart. The piece of AI that I interacted with to ask questions, or even simple things like "Hello, how are you?" or "What can you do?" was done by Google Dialog Flow. And Google Dialog Flow gives you the ability to have these natural conversations, but it also gives you the ability to configure and train your chatbot for a specific purpose without to be sort of a natural language expert or having to go out and hire one. And then Stitch, again, provided the ability to bridge the two platforms together, from my operational app to my piece of AI, to actually fulfill the intent, which is, giving you a product from my product catalog, as opposed to just generically, having a nice chat with me. And then Slack was the way to kind of deliver that user experience. So again, as we discussed, who are the folks who would do this? So our developer obviously build our app. The data scientists would be either involved in configuring and training a piece of AI like provided by a Dialogflow or your own natural language processing framework. Then a data engineer is probably going to get these things to kind of fit together and scale them. And then the developer and the data scientist can work together to make sure that that piece of natural language processing software or that chatbot is actually able to be embedded in the operational application. So let's talk about this architecture briefly. And the idea here is that we have a user who either, in today's world can actually also speak to the chatbot, or as you saw me do, input a query. That query gets translated into intent. Then that intent gets fulfilled. In our case, that fulfillment happens through a service webhook, but a reverse service webhook through Stitch. And then the data is sitting in our MongoDB Atlas database. So Stitch functions are able to retrieve that data and then return it back as fulfillment, as intent fulfillment. And that's the actionable data you saw when you saw me get that jacket back. So the idea is that you can have a sort of rich and natural conversation, like "help me find a jacket." Perhaps you would also get a little bit more specific with color. And Dialogflow will have a variety of intents and entities. So for example, it recognizes, finding a jacket as a shopping intent, which you would configure. It would also then recognize that you're looking for a specific color, and kind of map those two things together and provide the ability to go get a fulfillment to your request. So in this case, we had to configure a bunch of intents and entities. So searching for item was one, and the entities associated with that intent were color and the product. And the response and the fulfillment, the response to that request was to go get a fulfillment through a webhook, which was enabled by Stitch service integration. So in Stitch, what we had to do was to provide that reverse webhook back, as we just saw in in the previous slide from Dialogflow into Stitch so that the two platforms could talk to one another. And then basically the effective kind of mechanism for communication is still an HTTP GET. In this case with a payload. And the one important thing that I wanted to point out here is that we do have security here enabled by default. So, here we have multiple sort of cloud platforms talking to one another. Obviously, you want to secure that communication. So in addition to sort of, TLS that's encrypting data in flight, we also are providing in Stitch an ability to have either a signature or a secret that you can share to make sure that communication is secure, which is obviously something that we always want to have there without having to spend a lot of time actually doing the work ourselves to enable this. And the next bit that we had to do to make this actionable was actually write another function to do a couple of things. So the effective method for once we had the parameters from Dialogflow was to perform a find on MongoDB catalog using the color and the type of product that we're looking for. And once that item was found, we could then return item to Dialogflow as the effective payload, which would be the text plus the link to the product in question. And obviously we enabled rich messages because everybody wants to see a little preview of the item that they're interested in. And so as such, hopefully I've demonstrated to you that we can have a developer working on an application, whether it's a shopping application or any other kind of application, a data scientist who may be working on a variety of things, whether that's a recommendation engine or a churn predictor or a natural language processing API, and a data engineer who's able to both stitch things together, but also provide data to these multiple stakeholders. And with a platform like MongoDB Stitch and Atlas, obviously, we can make these different personas and these different tasks actually come together into an intelligent application. So hopefully that was interesting enough and inspiring enough for you to go and build your intelligent application next time that you are tasked with building a disruptive app or operationalizing your piece of AI. So hopefully I've showed you through these various steps how developers, data scientists, and data engineers can work together. And my call to action is, hopefully you can go put this into reality. We're excited to hear what you come up with. And to kind of get you started, we also have a $25 MongoDB Atlas credit, which will be good for using with Stitch, Atlas or Stitch, obviously. And the code is webinar25, so all capital webinar 25, and that'll get you $25 on MongoDB Atlas. Obviously, there's free tier. There's lots of ways to get started for free, but this should give you just a little bit more to kind of test some of these things out. And if you wanted to look at specific tutorials, we have lots of documentation on Stitch, on how to make service integrations, on how to write functions, and the Google Cloud ML tutorial that I talked about in terms of actually building the recommendation engine and understanding all the intricate details about the WALS algorithm and how TensorFlow gets involved, and all that code is actually available on GitHub, as well as in that tutorial. And the same with Dialogflow, lots of great resources to get started.